should have generated a few dozen ways of meeting our critical customer requirements. That was our goal as we discussed in the last module. This time around, we need to figure out which are the best ideas to take forward. So using a set of tools, we can down-select a few designs from the many your team has created. If you've heard of a Pew analysis, that's just one of them. Okay, you have perhaps 2 or 3 ideas you think are pretty good. Now what? It's time to build some prototypes, even simple ones, and get some customer feedback on which one they might like, if they like any of them at all. As engineers and technical people, we might have a very distinct idea about what prototyping is all about. But let's think about it differently. In this case, we want something the customer can play with. Of course, depending on a few factors, we might build something out of, say, cardboard if we're trying to get some relatively high-level information. Or we might build something more sophisticated. What to build as a prototype and when it's appropriate to show the customer is something that has really changed the past few decades. That brings us to MVPs. No, not most valuable player, but minimum viable product. This is an idea that filtered to the product development world from the software development world. It's all about building the simplest and least expensive thing possible, all in an attempt to elicit some customer feedback. Then what? It's time to test those out with some real customers and see what they think. This turns out to be a critical point in the project, as the level of sophistication in your MVP should reflect what it is you're really trying to learn from your customer. And as this whole thing is very much an iterative process, the more we know, the more complexity we can build into the next round of prototypes. And the cycle continues. And that wraps up this module. So let's stop talking about it and get right to it. In our last lesson, we talked about concept generation and some techniques we can use to design a wide variety of products that all meet our critical customer requirements. And if we're lucky, we ended up with many different design concepts. The question we want to answer in this lesson is, now what? It's time to down-select the team's ideas to a few meaningful concepts for further development. What I'd like to do now is introduce the concept of the voice of the business, the VOB. So far, we've been spending a lot of time talking about the voice of the customer, the VOC, and I think we understand the VOC pretty much by now. But remember, there's also the voice of the business. Not only do we have to keep the customers happy, we have to make sure that the product is going to be financially viable for the company too. And now we have to align with the voice of the business. Where those two things intersect is where everybody is happy. Customers like the product, and the business likes the financial returns it's getting on the product. So where do we go from here? In terms of the voice of the business, the VOB, you've pretty much defined your business objectives in your project mission statement, something we talked about in the last course. And that would cover things like this. What's the revenue opportunity? Meaning how much money are we going to make on this product? And of course, revenue is a combination of the price and how many we're going to sell, the volume sold. That means we have to forecast what the volume sold is going to be, something we're going to talk about in the next course. Then there are the gross margins, which are defined as the revenue minus something called the cost of goods sold, or COGS. The COGS pretty much define what it costs to make the product. So the gross margins are related to something called the gross profit. There's another term called contribution margin, which is the price minus the variable costs associated with the product, things like the raw materials and the labor costs to build it. That turns out to be an important financial parameter that the business wants to know too. And then if they're going to invest in it, they want to know, What's it going to cost to get this project off the ground? What's the R&D expense necessary? In essence, what is the business's financial returns for investing in this product development project? Now, we're not going to dive into too many of these details in this course. We're going to talk about that when we talk about the business case in the next course in the product development specialization. What we do want to talk about now is the idea of how we down select from all the different concepts that we've generated so far. Think about it. If we've done our job correctly, our team has probably put together somewhere between 20 to 30 different ways of building the product. We want to take all those concepts and put them through some sort of initial screening filter that allows only those concepts that meet the voice of the customer and the voice of the business to get through. That might whittle things down to just a few concepts. Let's say concept 8, 11, and 23. What can we do next? Well, going from 30 to 3 is a big step. Now we can do some other interesting things. If these are relatively simple products, we can go ahead and build some prototypes of these different options and then have customers evaluate them. If these concepts are more sophisticated than that, we may need to do some engineering analysis to figure out which ones make the most sense. Yet with these 3, we want to go through a final screening filter to identify which of these 3 concepts is the winner, the one that we're going to take forward into production. What we want to focus on for now are these various screening filters that allow us to determine the down selection process from the many concepts to the few. Let's talk about a few ways we can do that. In the concept generation phase, we might have 15 to 20 to 30 different ways of achieving our objectives, meeting those voice of the customer requirements and meeting the voice of the business requirements. Now what do? Prototyping, which is what we're going to spend a lot of time talking about in the next lesson, prototyping each one of those concepts is not only impractical, it just takes a lot of money. What we need is a way of getting the number of concepts down to just a few, maybe 3 or 4, allowing us to identify the most promising concepts that require further engineering development. Here's a way we can do this. Step 1 is just screen for the best concepts, using a relatively high-level filter. Then step 2 would be maybe conducting a more detailed engineering and cost analysis to get a better sense of what the actual product cost is going to be, allowing us to address more of the voice of the business requirements. Then we can go to step 3, selecting the best from the best that we have available. That's one way to do it. Let's now talk about the high-level filter of getting through this process. Let's try to take a look at how this high-level screening process might work. With your product development team, the first thing you're going to do is define the selection criteria that will be used to determine those concepts to take forward. Presumably, they all meet the VOC at this point. Now we have to figure out some of the next steps. Are they technically possible, for instance? What about the manufacturability of all these different concepts? How about their cost effectiveness? What do we think about reliability and durability? And maybe aesthetics might be important. All this feeds into how are we going to decide which concepts to take forward. Then what we can do is post sketches of all those different concept designs on the wall, like a whiteboard for example, with a brief description of each one. Then we would select one design as the reference concept, and then all the other designs are going to be compared to that one. And just so you know, the reference design could be one coming from your competitors. That's okay too. Once we've defined the selection criteria and we've posted all the concept designs on the wall so we can all take a look at them, and we have our reference concept, we create a table. The table looks something like this. It's a screening matrix of all the concept options. What we have here are the selection criteria in the left-hand column, and we'll use the same ones we talked about just a minute ago. Is it technically possible? What about manufacturability? How about its cost effectiveness? Is it reliable? And what about the design aesthetic? Now what we're going to do is we have our reference concept in the next column, and then all the other concepts following that one. Once we have that set up, we go to the next step. And that's the easy part. We take the reference column and we fill it with zeros, just like you see here. What we're going to do now is we're going to take a look at all the other concepts, at how they compare with the reference design. Here's how we're going to do that. We're going to rate each concept relative to the reference using a scale that goes from 0, which means it's the same as, to +2, which means it's much better than the reference design. Or it could be -2, meaning much worse than the reference design. I go through each concept one at a time, and I rate it relative to the reference. As an example, take a look at concept 2. For technically possible, we give it a +1, meaning it's more technically possible than the reference. Manufacturability, a +2. That means it's much more manufacturable than the reference. Cost effectiveness, +1, which means we believe we can build it at a lower cost than the reference design. Reliability, it's a 0. From everything we can tell, it's exactly the same. And then aesthetics, -1, meaning it just doesn't look as great as maybe the reference design. We go through this exact process for all the different concepts relative to the reference design. Now you're thinking, how do we come up with these +1s or +2s? We've never even designed this thing in anything other than a sketch that goes on the wall. And this is where the team comes into effect. You know, based on the team's experience, whether these concepts are better or worse in general relative to the reference design. And that's all we're talking about here. Yes, maybe it's a little bit more subjective than we engineers might be used to, but that's the way this process works. What we do next is we add up the scores and rank all the concepts, including the reference design. And what you can see here for the total score is the reference, well, that will clearly be a 0. Concept number 2 has a +3, which tells us that overall, it's a better design than the reference design. Concept 3, though, has a -6, which means it's probably a lot worse than the reference design. And then concept 4 has a +6, which tells us it's a lot better than the reference design. Now you can rank these from high to low, saying the best design on the table so far is number 4. That rates the best. The second best design is concept number 2. The reference design is number 3, and concept number 3 is clearly the worst. What do you think happens next? You just ask yourself, which ones do we go forward with? We eliminate those concepts that just don't make the grade. And at the end of the day, we can only take a few forward, and we've decided to take concept 2 and concept 4 to the next phase of product development. So now we've gone from 4 different concepts, including the reference, down to 2, all using this technique that we've now applied. If you've ever done this before, you may know this is known as the famous Pugh analysis, named after Stuart Pugh. After doing a little engineering analysis, this is a great way of getting your initially extensive lists of concepts down to something that's a lot more manageable. Ideally, a lot less than 5, and in our case, even fewer than that. Well, that sounds pretty easy, doesn't it? You just get your team to pairwise compare one concept relative to the reference. You throw out the ones that don't work, and you keep the ones that make the grade. And that's all there is to the Pugh analysis, which is one of the reasons it's so popular in industry. Now that we know about the Pugh analysis, where do we go from here? I'd like to talk about another technique of making decisions when there are multiple factors to consider, something known as the weighted attribute approach. You'll find it looks quite similar to the Pugh analysis, but incorporates a few other things that I think make it even better. But more to come on that one next time. I'll see you soon. In the last video, we talked about the Pew analysis, a very good way of down-selecting many concepts to get to a few. In this video, we're going to talk about an even more sophisticated approach, something called the weighted multiple attribute analysis. I think you'll find it's an even more effective way to down-select many concepts to get to the few you need to take forward. Let me show you how this works. We'll take the example of buying a car. Now, this is a big decision that you make probably just a few times in your life, and you want to make the right decision. When you're buying a car, the first thing to think about is what really matters to you. Something related to those decision selection criteria that we talked about in the last video. Consider that you're taking a look at these two vehicles. One is a Fiat 500e, the electric version of the very popular Fiat 500. It has a base price of about $18,000 or so. Now, it's obviously a lot more expensive than that because it's an electric version, but with all the rebates that you can get, that brings it down to the $18,000 point. It has pretty good gas mileage. The EPA says it's in that 121 to 103 range for an electric car. Now, it's an electric car, so miles per gallon doesn't make a whole lot of sense, but this is the way that the EPA rates these kind of vehicles in terms of fuel economy. I want to compare that vehicle to the Toyota Sienna. Now, the Sienna has a base price of about $37,000 and also achieves about 36 miles per gallon in terms of gasoline fuel economy. I'm thinking about either one of these two cars. What's really important to me? If I'm thinking about the Fiat, the important attributes I might come up with would include price, fuel economy, and styling. If I'm thinking about the Toyota Sienna, I'm thinking about space for everybody, safety, and fuel economy. All these attributes are important to me. The question then becomes, how do I take all these attributes into account so I can make a good decision on what kind of car to get? Because clearly, these are two very different kinds of vehicles, and I would buy them for very different reasons. But I'm really confused now, because they both have characteristics of things that I think are really important. What is it that I should do? Well, I would conduct a weighted multiple attribute analysis. And the way that we do that looks like this. Just like in the Pew analysis, we identify all the key attributes. What are those important decision criteria that I have in selecting a vehicle of one type or another? I would then assign an importance and weight to each of these attributes, and this is where things are much different than the Pew analysis. The Pew analysis assumed that all the attributes were roughly the same degree of significance. Now we're going to talk about each one of these attributes having its own importance, and therefore we're going to weight each attribute relative to each other. From there, we're going to rate each alternative, one car or the other, by the weighted attribute. We're going to calculate a figure of merit, we'll call it R for now, for each alternative. And then finally, we're going to select the alternative with the largest R value. Well, that sounds easy enough, but let's put it into practice. I have these two cars that I'm very interested in looking into. Step one in this process is to identify all the key attributes. What are our decision criteria? As I mentioned a few slides ago, the important attributes look like this: price, fuel economy, styling, reliability, and safety. You might have a few more, but let's stick with these for now and run through the analysis. Interestingly, more often than not, important attributes from a product perspective are often defined by the customers, the critical customer requirements, or CCRs, because that's what define their decision criteria. Okay, what happens next? In step 2, we assign an importance to each attribute and then calculate the weight of each attribute. How we do that looks like this. We rank order the attributes in terms of importance. We assign a value of 100 to the most important attribute and then assign an importance score to the rest of them. We sum up all those importance scores and then we weight each attribute by its importance value divided by the sum of all those values. Does it make sense? Let's see how it works in practice. Here's a table of all the attributes: price, styling, fuel economy, safety, and reliability. I said price is most important. That goes at the top of the list, and I'm going to give that an importance score of 100. Now, just to keep our terms straight, I'll call the importance score S sub I. That's the score. Styling is also pretty important, so I'll give that a 90. Fuel economy is important to me too, just not as important as styling and price. I'll give that a 70. Safety? I'll give that a 30. That's important, but I'm sort of making the assumption that almost all vehicles out there today are pretty safe. And then reliability, I'll give that a 10. Of course, reliability is important too. It's just not as important as all these other factors that I have. What I can do is I take my importance scores for each one and I add them all up. And the sum of those importance scores is equal to 300. From there, I can calculate the weighting factor for each attribute by just taking its importance score, S sub I, and dividing it by the sum we just created. So for price, the weighting factor is 100, the importance score, divided by 300, the total sum. That gives me a weighting factor, W sub I, of 0.33. For styling, I take 90, the importance score, divided by 300 again, and that gives me a weighting factor of 0.30. Fuel economy, 70 divided by 300 equals 0.23. You get the idea. Ultimately, all those weighting factors should add up to 1. That tells me I actually did the calculation correctly. Well, now what do we do? Step 3 is we have to take a look at each alternative, in this case the Fiat 500e and the Toyota Sienna, and rate each attribute for each of these cars. We're going to define a rating value for each attribute and apply it to both alternatives, both cars. You can use a lot of different scales for this. For convenience, I'll use something called the Likert scale, which defines a range of possibilities between 1 and 10, where 10 is a very strong rating and 1 is a very weak rating. For example, take styling. If I gave styling a 10, that would be saying, that's a very stylish car. I feel just really cool driving around in a car like this. But if I gave that car a rating of 1, that means I don't think that car has any style whatsoever. Maybe something only my parents would drive. I need to do this for each of the attributes, and let me show you how I did that. In rating each alternative by the weighted attribute, I'm going to give it a value for the Fiat 500e and a value for the Toyota Sienna. For price, let's just say I think the value of the Fiat 500 should be about a 9. It's awfully good considering it's an electric car. The Toyota Sienna, well, it's a lot more expensive, but it's also pretty typical for the average vehicle. So I'll just give it a 7. Styling, the Fiat 500 has it there. I'll give that a 10. Whereas the Sienna, well, it looks pretty good. I'm going to give it a 4, but I'm really buying it for things other than just styling. Fuel economy, I'll give the Fiat a 10 on that one too. And while the Sienna is pretty good, I'm going to rate it a 5. Safety, well, the Fiat's a lot smaller vehicle. I'll give that one a 5. Whereas the Toyota, well, it's a pretty robust minivan. I'm going to give that a 9. And then reliability, the electric vehicles probably haven't been on the market long enough to really get a sense of how reliable they can be. I just don't know. I'm going to give the Fiat a 4. The Toyota, on the other hand, we know that one's going to be pretty darn reliable. I'm going to give that an 8. Now you see how I've rated each alternative by these different weighted attributes. Now we have to do a little bit of math. Step 4 is to determine this figure of merit, what we called R, for each alternative. And the way that I do that is I take the weighting factor for each attribute and multiply it by the value that we just assigned to each car. So for instance, to get the R sub I factor, the figure of merit for price for the fiat, I take the weighting factor for price, 0.33, and multiply it by the value that we gave the fiat, a 9, and that gives me a figure of merit of 2.97. I do exactly the same thing for the Toyota. I take the weighting factor for price, 0.33, and multiply it by the value that I gave the Toyota, a 7, and that gives me a figure of merit of 2.31 for the Toyota Sienna. I do the same thing for styling. A weighting factor of 0.3 times the value for the Fiat of 10 gives me a figure of merit for styling for the Fiat of 3.0. The weighting factor of 0.3 times the value I gave the Toyota, 4, ends up with an R value of 1.20. You get the idea. You just go through that process for all the different attributes and you fill out the rest of the table. Then we're almost done. We go to step 5. We sum up all the figure of merits and we select the alternative with the largest R. Makes perfect sense, right? I add up all the R values for the Fiat and I come up with a value of 9.25. I add up all the values for the Toyota and I come up with 5.80. Well, based on this is telling me that I should buy the Fiat. It has a much larger figure of merit than the Toyota Sienna. So you see how this works? What it does is it takes all the attributes that are important to me and it weights them accordingly. Then I apply the values to each car based on all those attributes, and then quantitatively figure out how to incorporate the weighting factors to determine what's most important. Now that's different than the Pew analysis, where all the attributes were weighted equally. Now we've been able to say which one is the most important. And based on the attributes that are the most important to me, and how each car stacks up to those attributes, I'm now able to quantitatively determine that the Fiat is the better car for me. Even though I thought the Toyota Sienna was a great car, the Fiat matches up more with my decision criteria, those things that are most important to me. Now, of course, the weighted attribute approach the way we've done it does have a few challenges. For one, if you don't like your result, it's just too easy to reevaluate your inputs and kind of rationalize the result that you wanted in the first place. Well, that's easy to do if you're doing this by yourself, but a whole lot harder when you have a group of people involved. In fact, if there are more people involved in the ranking and valuation process, you have a lot of discussion going on to get consensus to get to the final result that everybody can agree to. Well, that's the weighted attribute approach. I think it's even more powerful than the Pew analysis. But I want to try this out with a real example, something that's probably quite important to you. Let's take a short break, and when we come back, we'll use the multiple attribute approach in helping us make a real-life decision. But more to come on that later. I'm Michael Reedy, and I'll see you next time. Now that you all know what the multiple attribute analysis is all about, it's time to put it into practice. And we're going to try something that's worked out very well in all of the courses where I talk about this sort of thing. Getting some help in making a real-life decision. In order to do this, first download the Work-Life Location Balance exercise from Course Resources. You're going to need it in this lesson because this will help you make a real-life decision. Here's the exercise, and I hope you find it a fun one. It addresses the Work-Life Location Balancing Act. And here we go. Your resume not only lists a degree from the University of Colorado Boulder, CU, but that you took a graduate product development course, which makes you a highly sought-after candidate for many opportunities. While you're happy in your current job here in Boulder, you have recently started thinking about next steps in your career. And after a few phone calls, you now have many options to consider. Which one do you choose? Here are a few options. You can certainly stay right here in Boulder, because right here is great. The position that you have is as a project engineer, the salary you're making is $120,000 per year, and the workload, well, it's about 50 hours per week. Manageable, but hey, I love living in Boulder, so this works out really well. But there's another opportunity, a high-tech excitement opportunity in San Francisco. It's the same kind of job as a project engineer, but now you're making $160,000 a year. Of course, it's a more demanding environment, and you'll be working 60 hours per week, which is a lot. But hey, it's in San Francisco, and that's a pretty cool place to be. The other option is in Milwaukee, Wisconsin, where you're not only a project engineer, but this is a real promotion opportunity to engineering manager. Now the salary bump is up to $140,000 per year, better than what you're doing here in Boulder, maybe not quite as much as San Francisco, but the workload is quite reasonable, 40 hours per week. And Milwaukee, Wisconsin, if you've ever been there before, is a beautiful city on the lake. A lot of advantages. One of the other advantages among all three of these options is cost of living. The cost of living in Milwaukee is a whole lot better than Boulder, and way, way better than San Francisco. And your $140,000 salary will go a lot further in Milwaukee than even a $160,000 salary will in San Francisco. Something to consider. You have another opportunity as a business consultant. Now you're making $200,000 per year, and you get to be in Boston, Massachusetts, which is a truly cool place to be. But as a consultant, you have to work for that $200,000 per year, and the workload ends up being about 80 hours per week. Now that's great because you'll be in Boston, but you'll be on the 20th floor of the office building looking down at all those people having so much fun because you're working all the time. However, think of how much money you can save in the process. There's an advantage to that, too. One more opportunity. Now you get to be an engineering manager again, a real promotion from what you're doing today. And you get to do it in Paris, France. So you're now part of the international jet setter community. That sounds pretty good. And the workload sounds rather manageable, at 40 hours per week. Mostly because that's the culture in Paris, France. They want to be able to balance life with work. Well, clearly it's not making as much money as any of the other opportunities or what you're doing right now. It's also working a little less from a workload standpoint, but you get to do it in Paris, France. On the other hand, $100,000 may not get you very far in Paris, France, because it's also one of the more expensive places in the world to live. But you still get to enjoy Paris. One more opportunity to consider, and that is something entirely different. Maybe you've been at your job for a while, and you have a chance to go be a ski instructor and a mountain biking guide in Aspen, Colorado, one of the most beautiful parts of the entire Rocky Mountains. So now this is a job less about advancement and money and more about inner peace. You're not making very much, $40,000 per year, but you don't really care because you're doing exactly what you have the most fun doing. And you're working 40 hours a week while living in Aspen, Colorado. What's not to love about that? Here are those 6 options. The question then becomes, how do you pick the right one for you? Like most things in life, the one job that's perfect in every category just doesn't seem to happen. You have to decide where the compromises are going to be. And you can use a multiple attribute analysis to identify the job that best matches your interests and your objectives, at least at this point in your life. So let's go ahead and do that. Here's what I want you to do. Take out the exercise and let's start filling it out. You can do this in Excel too, because that will make some of the calculations a lot easier. But you can do it any way you want, as you have both opportunities, both Excel file and just doing it in a handwritten format. But step 1 is always the same. Identify all the key attributes that are important to you, ranked most important to least important. Now, I've said position, salary, workload, and location as 4 of the attributes that are important to me, but they may not be the most important to you. Put down all the things that you want to put in here that you think would influence your decision one way or the other. Let's pause the video to allow you to do just that. Okay, you have your list? Let's go on to the next topic. The next thing I want you to do is to rate each attribute for all the different alternatives, those 6 jobs that we're now looking at. Start with job A, the one in Boulder, and rate each attribute either a 1 for weak or 10 for strong. All the way down the list. Those are the values that go in that value column. Then you would do the same thing with job B and the same thing with job C. You get the idea. All those opportunities that we're thinking about. Now you might be wondering, wait a minute, don't we do the important scores and the weighting attributes? Well, yes, but we're going to save that for the next step. But before we do that, go ahead and rate each job for each of the attributes on a scale of 1 to 10. And when you're done, come back and we'll go to the next step. Great. Have that all done? Let's keep going. Now we get to do the important score part. This is the first step of step 3. We're going to assign an important score for each attribute. Remember, the one at the top, the most important attribute, gets a score of 100, and the least important attribute gets a score much less than 100, and everything else is in the middle. Then what you're going to do is add all those up and put that total score in that box down at the bottom. Take a minute to do that, and we'll come back and go to the next step. Well, that was harder than you might have thought. It certainly was for me when I did this. Let's go to step 3B now. Now we assign a weighting factor for each attribute. Remember, the way that we do that is we take the important score and divide it by that total score in that bottom box. That shouldn't take too long to do. In fact, it shouldn't take more than a few seconds if you're doing this in Excel. But go ahead and do that, and we'll come back and finish off the rest of the matrix. At this point, you have all your attributes, you have all your important scores, you figured out the attribute weighting factors, and you have the values associated with all the jobs relative to each attribute. Now we have to calculate the weighted value, the figure of merit, for each of the jobs. The way that we're going to do that is just like we did it in the last video. We're going to take the value and multiply are important to me. The question then becomes, how do I take all these attributes into account so I can make a good decision on what kind of car to get? Because clearly, these are 2 very different kinds of vehicles, and I would buy them for very Welcome back. In this lesson, we want to talk about prototypes and prototyping, and how we're able to get some customer feedback based on the kinds of prototypes they can work with. Let's get started. One of the things that we can start to do is begin looking at a detailed analysis of each of the concepts that we've been working on. And depending upon your budget, your product development team has been able to down select a few concepts to do this in more detail. And that can mean looking at things from an engineering perspective, from a manufacturability or assembly perspective, cost perspective, or maybe even how customers are excited about the new idea. Now, when I say depending upon your budget, what I really mean is the bigger the budget, the more options you have to investigate. But for many of us, working with 3 to 4 final concepts gets us to be able to define the best one that aligns with both the voice of the customer and the voice of the business. But now the real fun begins. We get to perform all the engineering analyses and cost analyses to dig into the details of each concept. Think about this rather fun example. You work for a toy company, and your job is to create a new, fun, compressed air-water toy rocket. How do you do this? Well, let's take a look. First, we establish the goal. And the goal would be to create a toy rocket that can achieve the greatest height, which of course we would define as a CCR, a critical customer requirement, using air pressures achieved by an 8-year-old. Well, how do we do that? The first step might be to do some engineering modeling. Now we get to use your technical skills to do some preliminary design work. You start sketching out what a water-air toy rocket needs to look like. You know that you're going to be compressing the air inside the rocket. That contains some water. And the higher the air pressure, the more thrust you're going to get out of the rocket, and the higher it will go. So the question is the relationship between the air pressure, the amount of water available, and all the different mechanics of how this is going to work out. Welcome back. In this lesson, we want to talk about prototypes and prototyping, and how we're able to get some customer feedback based on the kinds of prototypes they can work with. Let's get started. One of the things that we can start to do is begin looking at a detailed analysis of each of the concepts that we've been working on. And depending upon your budget, your product development team has been able to down select a few concepts to do this in more detail. And that can mean looking at things from an engineering perspective, from a manufacturability or assembly perspective, cost perspective, or maybe even how customers are excited about the new idea. Now, when I say depending upon your budget, what I really mean is the bigger the budget, the more options you have to investigate. But for many of us, working with 3 to 4 final concepts gets us to be able to define the best one that aligns with both the voice of the customer and the voice of the business. But now the real fun begins. We get to perform all the engineering analyses and cost analyses to dig into the details of each concept. Think about this rather fun example. You work for a toy company, and your job is to create a new, fun, compressed air-water toy rocket. How do you do this? Well, let's take a look. First, we establish the goal. And the goal would be to create a toy rocket that can achieve the greatest height, which of course we would define as a CCR, a critical customer requirement, using air pressures achieved by an 8-year-old. Well, how do we do that? The first step might be to do some engineering modeling. Now we get to use your technical skills to do some preliminary design work. You start sketching out what a water-air toy rocket needs to look like. You know that you're going to be compressing the air inside the rocket. That contains some water. And the higher the air pressure, the more thrust you're going to get out of the rocket, and the higher it will go. So the question is the relationship between the air pressure, the amount of water available, and all the different mechanics of how this is going to work out. Being a technical person, you also recognize that the height of the rocket is determined by several factors, all defined by various equations which you get to solve simultaneously. Momentum equations, Bernoulli's equations, isentropic processes equations, and continuity equations. Well, how do you do that? Well, most of the time what you would do is set up a spreadsheet.
We are
at various routines to be able to solve them simultaneously. So you can set it up in a spreadsheet or using some software tools like MATLAB to be able to do just that. You then solve those using various simulation techniques based on certain design variables that we are really interested in. And you can plot out what's the relationship between height, air pressure, and water volume, for instance. From there, we would explore, well, how would we validate all of these models? We could create a simple experimental setup to validate the model that we've now just created in MATLAB or some other spreadsheet tool. And we would look at things like air pressure, water volume, and height to get a sense of how all these parameters work together. Then we go test the model to see what the actual values might look like. From that point, we can start building some prototypes. Now, sometimes it may be easier just to go ahead and build a few prototypes to see what works the best, but that's an approach anybody can take. I think our objective is to go ahead and use our engineering and technical knowledge to try to refine that process a little bit more. And that's why we want to talk about using these engineering analyses to get us to an even better prototype than we would have otherwise. If you want to see how this all might come together, take a look at this simple prototype to see how we might gauge interest. This is a really fun video to see how kids can build and react to a various prototype. Now, they may not know it's a prototype, but this is certainly how we might view something like this. Go ahead and take a second or two to click on the YouTube link to watch this fun video. Well, that's what I think is really fun. And of course, now that we know about the different kinds of ways of putting a prototype together that's really simple, we can go test this out without too much trouble. As we're going to find out, with prototypes, step 1 is to start out with something simple, and then step 2 is to add some complexity based on what you learn in step 1. Take a look at this video, which certainly takes prototyping to a whole different level when it comes to an air-water rocket. This is another fun one. In fact, this prototype is a lot more complex. Take a look at this one and see how high this rocket can fly. Well, there you go. Pretty impressive, huh? You just keep building on the knowledge that you have from simpler prototypes to come up with something that's really quite impressive. So this idea of creating some prototypes, let's first define what we mean by a prototype in the first place. Wikipedia defines prototypes this way: an early sample, model, or release of a product built to test a concept or process. Now, in its broadest sense, prototypes are many different kinds of things. They could just be concept sketches in their simplest form, or even some mathematical models like we just built for our air-water toy rocket. It could be various simulations that we might be able to do. We could test individual components to see how the components work and then put them together to see how the systems work. We could develop something called a look-like model, where it's not really functioning, but it certainly looks like the real thing. Or we could develop fully functioning models in various simplified forms to be able to show people this is how it could be done. In many cases, prototypes can exist in two different forms. Those analytical types that we technical people like to get involved in when we're developing some software models to look at these things. In the world of digital transformation and digital engineering that we're seeing now, many of these models incorporate some functionality, and therefore we call them the digital twin, prototypes that are all built with software. Of course, in many cases, we have to build something in its physical form, and things like 3D rapid prototyping really help us to get there. In some of my classes, we build some prototypes out of simple foam core board. In fact, one of the exercises that we have to go through is to build this train ticket kiosk that is made 100% from very flat foam core board. And the students have to cut it out in certain ways, glue it together, to form this three-dimensional product prototype. What's really fascinating, though, and this is the other half of the assignment, is that for less than $5 in raw materials, you could make a prototype and then superimpose it into the application that you're really interested in. So while part one of this exercise is where the students have to make the prototype, as you see on the left-hand side of the screen here, the second part of the exercise is they get to superimpose it in the application where it's designed to go. In this case, it's a ticket kiosk for a train station, so you would expect it to go into a train station. And here it is, inside the office of an Amtrak station. Now, how did they do this? With just some simple photo editing tools to go from that prototype that's maybe 15 inches tall to something that looks like the real thing. I think this is really clever. And rather than have to build the entire device that is sort of in full scale, you can use some simple photo editing techniques to be able to do the exact same thing, all for less than about $5 worth of materials. Here's another fun example. Look at this one. It's got a slightly different display screen on it, and it's placed inside with these modern train stations, now with a person actually using it. I thought this was pretty fun. And here's another example of a rather simple device that when you superimpose it, in this case on the train station at Denver International Airport, it certainly looks like it belongs there, with some photo editing techniques that create a shadowing effect that allows it to look about as realistic as it possibly can. So even simple prototypes that you can build for very little money and with very little skills, you can demonstrate to customers what you really have in mind. And that's the advantage of all of this. Well, with that as a foundation, let's take a break and we'll come back and talk a little bit more about prototypes and prototyping. I'll see you soon. In this video, we'll talk about prototypes and prototyping, different kinds of ways we can do all of this. Let's get started. If you really think about it, the primary function of producing a prototype is to learn something. For those of us on the engineering or technical side, we want to know, is this idea even technically feasible? From the business or operations side, we certainly want to know, is it possible to even make this thing we're thinking about? And from a functionality standpoint, will it work the way we wanted it to? We certainly designed it to do something specific. Will it actually do that? And of course, we have to be able to explain what we're doing to upper management so they can keep the funding flowing. And by having a prototype, we can show them this is what we're talking about. Of course, we also need to get a lot of customer feedback. And that means we want to know if people will really want this. And if so, how many people will really want this? Prototyping costs money. Anytime you have to make anything, it's going to cost money, whether it's a digital device or a physical device. And the first thing you need to figure out is, what are you trying to learn in the prototyping process? Because what you need to know determines what it is that you have to build. Think about it this way. Prototyping allows us to address two different issues. One is, does it work? And these are classic engineering-related issues. Is it technically feasible? And did it meet the specifications that we lined up when we did our product requirements matrix? The second question is, does anyone actually care if it works? And this is where customer development comes into play. Do people like it? And do they like it enough to buy it? And certainly need to know. And generally, we tend to focus on just those on the left-hand side, those sort of engineering-related issues. But as we're responsible for the entire product development effort, we also need to understand the customer sides of things. And that's why we're spending so much time talking about this. Many of you know, when we're talking on the engineering side of the prototype space, that there are certain terminologies that we use for things. There is something called the engineering test bed, which evaluates components, subsystems, or systems in a very controlled experimental fashion. Think about that technical readiness level, the TRL, that we talked about several lessons ago. Then there's something known as the alpha test, which evaluates whether the design will function as intended. Usually the prototype in an alpha test is pretty rough. You may not want your customer to see it because there might be like a lot of duct tape everywhere. But the alpha test certainly helps determine all of the technical functionality of what it is that you're trying to design. Not surprisingly, after the alpha test comes the beta test. Now the design is closer to the final production version, and beta prototypes allow customers to get involved and see and feel how the product functions. At the same time, because it's in the customer's hands, you get to assess reliability, durability, and any remaining bugs that might exist. From the beta test, we can go to a pilot test. In a pilot test, prototypes might be manufactured as pre-production units to test the manufacturing process. Up to this point, many of these prototypes have been built in the lab, one at a time. And now we get to look at how things work when we make many at a time. It's also used in preliminary field trials by customers to determine the durability and any unforeseen issues from operating the prototype in a real application, in a real field environment. Those kinds of circumstances that you just can't replicate in a controlled laboratory environment. Okay, these are things that many of you have probably experienced. Let's start segueing to how we would start constructing some of these prototypes. Earlier, we discussed sometimes nice sketches give customers a great idea of what we're talking about. There was an interesting study done by some researchers several years ago that took a look at different sketch quality and asked customers which image allowed them to provide the most valuable input into the product's design. And here's an image from the paper they published, where you can see several different designs, a cube, a chair, and a cell phone, and then different degrees of quality of the various sketches. What they wanted to know is if you showed this image to customers and you said, we need some input to figure out how to improve upon these various designs, which image would the customers pick where they felt they could provide the greatest input? Where do you think they would end up? Something pretty rough, or these sort of 3D rendered images on the right-hand side of the screen? It turns out they picked this one, something that was still a sketch, but not quite in its refined 3D rendered state. In fact, according to Macomber and Yang, it was anticipated that respondents would generally find the most finished, realistic sketch the most appealing. However, the highest fidelity hand drawing were the ones that were most favored. Now, why do you think that's the case? When they got some feedback from customers, they asked them why did they pick this one, and their responses sounded something like this. When you looked at the sketches on the far left-hand side, they were too rough, almost to the extent that the product designer didn't really think well enough about what they were trying to accomplish. On the other hand, those 3D rendered, very realistic-looking models on the right-hand side of the image, those were already done, and the customer felt, well, I can't influence this because you've already designed it. It's that hand-drawn sketch in column G where they said, oh, I understand exactly what you're trying to do, and this is how I would change it to match my requirements. As a result of studies like this, I certainly spend a lot of time in my class having people just sketch things out, even if they feel they have no artistic capability whatsoever. Because, as we've found out in many cases, even sketches give you a great idea of what the product concept is all about. So don't discount your ability to just write something up on the whiteboard and let people understand what it is you're trying to do. There are lots of different ways you can make prototypes. Just remember, the idea is to simply give the customer something to evaluate. That could be paper representations, something that we're actually going to do when we talk about digital prototyping. You could make a foam core mock-up of the device, like I showed you in the last lesson. Again, with just a few dollars worth of materials and some clever imaging, customers can get a really good idea of what it is you're trying to accomplish. Or you could make a number of other mock-ups, maybe in this case out of wood. These are just miniaturized models made out of balsa wood, but they certainly give customers a great idea of some of the designs that you have in mind and something that maybe you could scale up a little bit later. These are all certainly doable using low-cost materials and low-cost manufacturing processes. Of course, many of you are very familiar with 3D printing, prototyping made easy in this case by building a 3D model using various software packages and then download the model to various 3D printing machines. And you can make all sorts of things out of this. Designs that you would never be able to make using conventional CNC milling machine operations to products that might have some degree of functionality, like perhaps this shoe that you see right here. If you're not as familiar with prototyping or the variety of things that you can do with it, check out this interesting video on 3D printing. It covers all kinds of cool ideas that can be made with additive manufacturing techniques like this. Another technique in 3D printing is called stereolithography. Now, this is a much different kind of machine, and it turns out to be a much more expensive kind of machine. And stereolithography allows you to build different types of prototypes using a UV curable resin. If you've never seen this actually happen in practice, watch this interesting video to see what stereolithography is all about and how it's different from additive manufacturing processes like in the last video. Pretty interesting, right? That's what I thought. Now, stereolithography has been around for a while, and you can buy desktop machines like this, or you can buy full-scale industrial-type machines like this. In any case, stereolithography is a great way of building realistic-like prototypes that provide customers something tangible to work with. Okay, now that we know about what a prototype is and how we can build one, let's talk about something else in product development, something called the minimum viable product, or MVP. If you've been following this course from the very beginning, this should all look quite familiar. But of course, like so many things, the terminology is a little bit different. Let's dive into the details of the MVP to understand what people are really talking about. I'm Michael Reedy, and I'll see you next time.
Sao đâu mà chỉ có 9 tỷ một căn?
Let's talk about prototypes and the minimum viable product, the MVP. The basic idea behind the minimum viable product is pretty simple. Don't think too much at first. Build some MVPs, measure the feedback you get from customers, and learn about what works and what doesn't work. Then build the next generation of MVP. Now, why don't we want to think about this too much at first? Because we start overanalyzing what we think the customer might want. And when we do that, we're making too many assumptions. It's better to start off with something simple and go find out directly what the customer wants. That's the whole idea behind the minimum viable product. For those of you that have been with us from the very beginning of this course, this might look familiar. The whole concept of design something simple, build it in a simple prototype, and then test it with customers, learn something, and then design the next version of it, is the same basic model Professor Alice Agogino created as a professor of mechanical engineering at Berkeley when she developed this product development approach for the Jet Propulsion Laboratory. And while quite a simple idea, this has become the mantra for the lean startup movement, now tied to something called the minimum viable product. So what do we mean by this? The MVP, minimum viable product, is the simplest prototype you can create that captures the essence of your value proposition. Now, it can be in many different forms. It can be something functional, the MVP with the most basic feature set required to get useful customer feedback. That's what you start with. It could be something like just a data sheet, specifications that define your product's value proposition, even if you've never actually built it yet. It could be a marketing brochure, brochures defining your product's value proposition, even if you're not sure what it is yet. Interestingly, I have a colleague that designed a low-volume canning operation for microbreweries. And in order to figure out whether anybody actually wanted a low-volume canning operation for microbreweries, they took a number of data sheets and a few brochures to a microbrewery conference to see whether anybody cared or not. Turns out, microbreweries love the idea of a low-volume canning operation because that was something they weren't able to do on their own. And with that basic information, my colleague was able to work with his engineering buddies to come up with something that was quite commercially viable. All because they had data sheets and brochures without an actual product in front of some customers. They learned a lot, and as a result, they had a successful product line. Of course, there are other ways you can do this too. There's this thing called a storyboard, illustrations of customers maybe using your product idea. Again, all we're trying to do is elicit some customer feedback, and there are lots of ways we can do that. You can even create a landing page on a website. And as we're going to see a little bit later, on your landing page, you can just ask the question, how many of you have this problem? If you do, click here. And you can get some ideas about whether people have the problems that you think they have. Once again, the whole concept of the minimum viable product is to learn something about the customer and what their needs might be. And you don't want to spend a lot of money doing that. And all of these approaches will allow you to get some of that information quite effectively. Let's talk about some terminology here when we talk about MVPs. Here's a simple example to explain the basic concepts. You have an idea for the actual product that you'd like to be able to sell. This is your vision. Now, maybe you're not there yet, but you get the idea. This is your vision of what's going to happen. How would you use the minimum viable product concept to test whether anybody would like this idea? You would start with something called a low-fidelity MVP, which I would define as just a super simple prototype. Anything that you can show a customer early in the development process. And I would call this step 1. If your vision of the final product is a portfolio of donuts with a variety of toppings on them, then what do you think the low-fidelity MVP might be? Well, I would think maybe it's just something like this, a very simple plain donut. Because let's face it, if they don't like the plain donut, they may not like it with all this extra stuff on it. They have to like the plain donut first. And once you have them agreeing that this is a good concept, you can move to the next step. What do you think step 2 might look like? We go from a low-fidelity MVP to a higher fidelity MVP. And now this is starting to look like a real product. This would be something you can show a customer too, once you know that they actually like the concept to begin with. They might even order a few, which would allow you to really assess whether customers like your idea. And based on that, what do you think the higher fidelity MVP might look like? Well, remember, the concept is you take the low fidelity MVP, and once people like that, you start adding more complexity to it. That might mean you put simple coatings on the donut. So maybe a chocolate coating, or maybe just a sugar glazed donut, something along those lines. And if you get a positive response for your high fidelity MVP, you can be much more confident that your actual product is something they're going to like too. Okay, this was a fun example. Let's look at a real product concept and figure out its various minimum viable products. So here's the idea. The actual product is an app that performs some sort of function for the customer. Now, based on that, what do you think the low-fidelity MVP might look like? Once again, it's a super simple prototype that you can show the customer early in the development process. Well, we're going to find this out in future lessons. But the low-fidelity MVP in this case might be just a number of hand-sketched wireframes that give the basic idea of what the app is going to do. If they like that, then you can take it to the next step, the high-fidelity MVP, where things start to look like a real product. What might that look like? Well, that could be various mock-ups that you would create. You would take your hand-drawn wireframes and then create the mock-ups that look something like this. Not quite the actual product, but something that, from a prototype perspective, looks like the actual product. Probably not functional, but that's okay, because the customer can interact with it as if it were a functional product. And there are lots of tools to help you do that, as we're going to find out in future lessons. That's the idea of the minimum viable product, the low-fidelity MVP and the high-fidelity MVP. But let me introduce another term that you might hear about. How many of you have heard of the term prototyping? Well, I have to be honest here. I've never heard that term in any of my industrial product development days. However, I have heard it talked about now when I talk to my mechanical engineering students. How do they define prototyping? Here's how the